Hello again, welcome to another review session. This time we're going to work through an actual practice paper. So we're going to work through a specimen paper here. I feel bad that I took so long to get the video up, but I'm actually going to try to go through two tonight, all right? So you may take a bit of time through this one since it is going to be the entire 1 hour length exam. I recommend skipping to the parts where you need the most, but if you do want to just follow along, by all means, that's what this video is for as well. So without further ado, let's dig into this exam. First of all, some advice for when you're taking these exams. If you come across a question that you don't know how to do, or that you think is going to take quite a lot of time, go ahead and skip it. Come back to it at the end. Do all the problems that are easy first, then go back and do the ones that are maybe going to take time but are worth more points. Here you can see how many points that each one is worth. And then finally, try to tackle the ones that you don't know how to do or the ones that are really hard and not worth so many points. All right, let's go ahead and dig into actually how to do this. We're going to see that most of these hopefully aren't quite as scary as we think they are. Let's go ahead and put these in blue. Blue's a nice color. So here we want to choose a suitable, just an appropriate metric unit. So meters, liters, kilometers, grams, and so on, to measure each of the following. So here we want the mass of a letter. Mass is going to be grams, kilograms, and so on. A letter is pretty small, so I would say that grams is probably our best option here. Next, we have the height of a house, unless you live in, well, no, even if you live in a tall house. If you live in a super baby house, maybe you'd use centimeters, but maybe a doll house, but a normal house, you're going to be using meters. And finally, the capacity of a bath. Generally, really the only units that we use are going to be milliliters and liters. So liters being the bigger of those is likely the best unit to use here. Okay, to solve this equation, we're going to be using inverse operations. So work through BIDMAS backwards, essentially. So the last thing we do would be add. So here we're going to do the inverse. Subtract. That's going to cancel. Do that to both sides. We're going to get 4b equals 39 minus 11, which is 28. Now this is like 4 times b, so the opposite of times is divide. We're going to divide by 4, which cancels. And we're going to be left with b equals 28 divided by 4, which is 7. So our final answer here is 7. Next, a carpet costs $15 per square meter, and the total delivery charge is $21. So it doesn't matter how much carpet we buy. If we buy 1 square meter, they're going to charge us $21. If we buy 5,000 square meters, they're also going to charge us $21. Maybe in the real world they'll charge us a bit more because that's a ton of carpet. Anyway, Peter's going to buy N square meters of carpet. We don't know how many that is. It's just some number. But we know that for however many he buys, he's going to be charged $15 for each one of these n's. So we can just take this n times 15, or in algebra we put the number first, so we have 15n, and whatever they charge that, they're always just going to tack on $21 at the end. So we can see this matches up identically with this one. So we need to take the expression which represents the total cost in dollars. That's going to be this one here. So moving on to the next page. Already one page in. Look at us. Okay, so the chart here shows the number of units of electricity produced each day of the week. Really quick note, this is paper 2. This is a calculator paper, so I will be pulling up the calculator from time to time. So the chart shows the number of units of electricity produced each day of the week. Over the 7 days shown, we want to calculate the total number of units produced. So we can see here, we just read and add all these together to save us some time. I'll just plug it in the calculator over here. So we've got 8 plus 14 plus 16 plus, what is it, 10 plus 8 plus 6 plus 6 plus 8 plus 6 plus, not 62. My goodness. Well, my calculator seems to not want to work anymore. That's wonderful. Okay, well, trying again because, all right, sorry to waste your time. 8 plus 14 plus 16 plus 10 plus 8 plus 6 plus 6. I didn't mess up. I just wasn't reading my calculator correctly. Sorry. Sorry for wasting all time. So anyway, when we add those all up, we should get 68. And now we need to calculate the mean number of units produced per day. Well, we're going to take this number and divide it by however many days we have, which here is 7. So we take 68 divided by 7, which will give us this beautiful number. So let's go ahead and round it to a nice, decent number. I did do this quickly, right? 38, 48, 56. Yeah, I did do that right. Okay, so we'll just round this to say 1 decimal place, right? 9.7. Or we could even do it to 2 decimal places. 9.71. Again, I'm saying 71 because after the 1 I've got a 4 that's going to round down, so I still have a 7.1. You could probably just say 9.7 as well, and that would be fine. Okay, so moving on to the next page, because that's already one page. These pages on the real exams don't have many problems, thankfully. That's why they give you so much space to do your work, which is why you should always, always, always show your work. My goodness. Okay, the table shows hourly rates of pay in a factory. We've got $7.20 per hour during the day, $8.80 per hour during the night. So Sanjeet works for 6 hours during the day on Monday and 5 hours on Tuesday night. How much does he earn altogether? So we just simply take 6 times this for the day rate, 5 times this for the night rate, and then we're going to just add those two together. So if you want to do this all in one action on your calculator, you could even use brackets to help get your big mess going. So let's try it. We'll take $7.20. Please get interesting. Okay, so $7.20 times 6 and bracket plus new bracket $8.80. I'm just going to put 8.8 times 5 and bracket. That should give us our answer of 87.2. Be careful when you're dealing with money or when you're dealing with dollars. You cannot just leave a 0.2 there. If you have anything that's not a whole number, as you have here, you don't just have 8.8, you have $8.80. Because dollars, pounds, euros are all divided into 100, so you should always have 2 decimal places unless it is a whole number. So we have 87.20, right? And just to check our work, because I'm always super paranoid, 7.2 times 6 is going to give us 43.2. And 8.8 times 5 is going to give us 44, which does put me much more at ease now. Even if you use a calculator, you should show your work somehow so I can see what you're doing, what you're thinking, and if at all possible, like again, this is worth 2 points. So if I see some sort of work but you make a mistake, I can probably at least give you 1 point if you are at least somewhere close to having the right method. Down here, a cuboid has dimensions 8 centimeters by 5 by 14. To find the volume, we simply take width times height. So width times length times height. So we're going to take 8 times 5 times 14, which, according to our handy-dandy calculator, 8 times 5 times 14 is going to give us 560. 560 what? Cubic centimeters. They already give us the unit, so we can just leave it as is. Moving on now to the next page. A teacher asks all the students in her class to write down an algebraic expression. Julie writes down 4n minus 5. Jim writes down 2n plus 14. We want to find out what value of n makes these two expressions equal, and we must show our working. So again, you see here it's worth 2 points, so there's going to be something here, and if they tell us that you must show your working, almost always, they have explicit notes in the way to grade these that if you don't show any work, you don't get any points, even if your answer is correct. Too bad, so sad. So we take 4n minus 5. They said they want them to be equal, so we're going to set them equal to each other. 2n plus 14. What I recommend here is getting your n's on one side and your numbers on another. So let's take our n over here. We're going to take the minus 2n. And let's take our numbers to the other side. To get rid of this, we would do the opposite. So plus 5 and plus 5. So here we've got 4n minus 2n is going to give us 2n. 14 plus 5 is going to give us 19. So 2n equals 19. If we divide by 2, n is going to give us 9.5. And if you plug these in, 4 times 9.5, that would give us what? 38 minus 5, which is 33. And 2n times 9.5, this is going to give us 19. Plus 14, again, is going to give us 33. So we do see that this works. We've already checked our work as well. Double check so we can move on and forget about this. Pupils in grade 7 and grade 8 can study either Arabic, Spanish, or Mandarin. Complete the two-way table. Alright, so we did this in our other videos. Taking a look here, we're just going to fill in which rows or columns are missing only one cell or only one area. So we have our total of totals. We have the total Mandarin, total Spanish. That means we're only missing the total Arabic, so we can take 120 minus 50, which is 70. 70 minus 37 is going to give us 33. So the total for Arabic is 33. Grade 7, there are 11, so that must mean 33 minus 11. There are 22 in grade 8. So that means that also here for this total, we have 120 minus 45. That is going to give us 75. So what do we got here? 75 minus 22. That's going to give us 53. 53 minus 19 is going to give us, what, 34? Okay, 50 minus 34, that's going to give us 16. And 37 minus 19, that's going to give us 18. Let me double check. 11 plus 18, that gives us 29. 29 plus 16 does give us 45, so we are good. Usually when these are worth 2 points and you've got several of these, it's going to ask that you get anywhere from 80 to 90% of these correct. So here, we can check the answers a bit later, but you would likely need to get 4 or 5 of these correct for at least 1 point. Not half. It will definitely be more than half. Okay, look at the diagram below. We have a triangle here. We have a line drawn, a vertical line at x equals 1. First, we went around to write the coordinates of point B. That's hopefully simple enough. B is here, right? So remember, our x comes first, so we see that this is going to be x is 4, and y is at 3, so we have the points 4, 3. And now the triangle, let's zoom out a bit, the triangle ABC is reflected in the line x equals 1 to give a new triangle PQR. We need to draw the triangle PQR on the diagram. So reflected means it's like a mirror, so it's going to go on the other side of this line. I recommend not looking at this so much as a shape, but as a set of points that are connected. So point A, reflected here, is 1 away. So we're going to draw one away in the same direction, put a point. So it says A, it starts there, so that would be P. Okay, B is next, which will be Q, so that's 1, 2, 3 away from the line. So go 1, 2, 3 here, put a point. It's going to be Q, and C is 1, 2 away, so here 1, 2, put a point. This is going to be R. So we have our triangle now, PQR. Okay. The original triangle ABC is rotated 90 degrees clockwise about the point 31 to give another triangle. We need to write down the coordinates of the new position B. So rotated means it's going to be turning 90 degrees clockwise. So we're going to go 90 degrees in a clockwise direction, same as the clock. And about the point 31. So that's going to be our center of rotation. So let's go ahead and take a look up here. The point 31, let's use a different color. It's actually going to be where C is originally. If we rotate it 90 degrees, that means that B is going to come down. So instead, let's follow our path here. We go 1 over, 2 up. Whenever we rotate this, it's going to be like going 1 down, 2 over. So that would be our new B. Let's call it B prime. So this is going to be at the point 5, 0. So go ahead and write that in here. 5, 0. And the diagram is drawn on a 1 centimeter grid. Work out the area of the triangle ABC. Wow, this is a very complete question. So let's take a look back up here. ABC. Let's find our flat area. We'll call this it, AB. This has a length of 2, right? So our base is 2. Our height, again, is also 2. And remember, our area of a triangle is base times height divided by 2. So we take 2 times 2 divided by 2. It's going to be 4 over 2, which is just 2. So the area of this triangle is just going to be 2 square centimeters. All right, ideally you do this work here. I did it up there. You need to somehow show your work. Okay, moving on. Andy, Brian, and Charlie share $72 in the ratio 2 to 3 to 4. Work out how much Brian receives. So Brian is the guy in the middle, poor middle guy, and we need to figure out how much he gets. So first we need to figure out how much is one share. The way that we do that, figure out how many shares there are in total. So we take 2 plus 3 plus 4, which is going to give us 9. And we're going to take the full amount and divide by the full number of shares to get how much one share is worth. So we see that one share is worth 8. And then we're going to go through the ratios to figure out how much each one would get. So Andy would get 2 shares. So we take 2 times 8. So Andy would get $16. But we're interested in Brian. Brian is this guy in the middle. He gets 3 shares. So we're going to take 3 times 8, 1 share, to give us 24. So Brian is going to receive $24. Moving on to the next one. The grid shows a straight line with the equation 2x plus y equals 12. Beautiful, beautiful straight line. All right. We have a different equation now, y equals 2x plus 2, and we want to complete a table of values for this. So they give us some values 0, 2, 4, and 6. They show you that whenever you put 0 in here, 0, so 2 times 0 is 0, plus 2 is 2. We're going to do the same thing here. We're going to take 2, put it in here. 2 times 2 is 4. 4 plus 2 is 6. Let's go ahead and write that out. So 2 times 2 plus 2, that's 4 plus 2, which is 6. So then we take 2 times 4 plus 2, that's 8 plus 2, which is 10. And then we take 2 times 6 plus 2, it's 12 plus 2, which is 14. So we have all these now, and next they want us to draw this line on the grid. So if we use our table of values, we can actually just see that these are all going to be individual points on one big connected line. So we can go to 0, 2, to 6. Be careful how they've got this spaced out. We got 4, 10, and 6, 14. And then using a ruler, you take these and you draw a nice, beautiful straight line. Not like that. That connects all these points. Unfortunately, I don't have a ruler, but you get the idea. Okay, so if we're going to be using this graph here, we can see that these two intersect right around this point. Right, so we can see that this is going to be about 7 and about 2.5. We want to try, we could plug these both in and see this out. I assume this is going to be our solution. I haven't looked at the answer sheet yet, but another way we could work out the solution to the simultaneous equation would be through either substitution or elimination. If we use substitution here, we see that y equals 2x plus 2. So we're going to put this in the other equation instead of y. So we'd have like 2x plus y. Instead of y, we use 2x plus 2 equals 12. So this is, we simplify, this is 4x plus 2 equals 12. We move this over, 4x, so, well, no, we've already moved that over, so 4x equals 12 minus 2, which is 10. So when we divide by 4, x equals 2.5. Ah, look, looking pretty good. Now we just plug this back into either one of our equations. Let's use this one, it's a bit easier. So y equals 2x, which is 2 times 2.5, right? Plus 2. 2 times 2.5 is 5, plus 2, so y equals 7. So we've solved it graphically, and we've solved it with substitution. X equals 2.5. Okay, so moving on. Tim, thinks of a number, and his number rounded to 2 decimal places is 5.46. What is the smallest possible number Tim could have thought of? Okay, well, this could be rounded up from something. If he rounded up from something, that means we're going to have a 3rd decimal place. So 5.4 something something. If he rounded up, that means that he would have had to add 1 to 5. And the lowest number he could have rounded up from would be 5. And then if you want, again, everything after that, don't think 111, actually be 000, which you don't have to include in decimal, so this is already a sufficient answer. In fact, this is the answer. Moving on down, this diagram shows pentagon ABCDE, and we know that this angle equals 118 degrees. Explain how you can tell from the size of this angle that the pentagon is not regular. Okay, there are a few ways we can do this. If we know that there are, well, in fact, let's presume we don't know this. How many degrees are there in a pentagon? Okay, we can take the number of sides, subtract 2, multiply by 180. That's going to give us the total degrees in a polygon here. So this is going to give us, right, 5 minus 2, it's going to give us 3 times 180, which is 540. So there are 540 degrees here. We could subtract this and then divide it out, and we're going to see that these are all going to be less. Or we could even see that if we want to find out how big each one should be in a regular triangle, we just divide by n. So here, divide by 5, which will give us 108. Well, 118 is not 108, so we can say that a regular pentagon should have 108 degree angles. And you could say something about how every angle should be the same if it is regular. You could also take a look, for example, at the exterior angles, right? Every polygon, the exterior angles add up to 360. This is a different explanation, let's use a different color. So in a pentagon, if you divide them all out by 5, you should get that a regular pentagon's exterior angles should always add up to 72. Here, however, if you look here, this exterior angle would be 62. So you could also write an argument showing this. But let's go ahead and move on to the next page. All right, page 10. Hey, we got some progress going. Okay, factorize y squared minus 8y. What can we divide both this and this by? I'm hoping you said y because that would be correct. Y squared, remember, is like y times y, so we can take a y out. So y squared divided by y is just y, minus 8y. 8y divided by y is just 8, and we're already done. y minus 8. Next we have a train timetable shown below. I'm going to zoom out so we have all the questions showing. So Grace wants to travel from Staveley to Kendal. Okay, so she's going to start in Staveley and she's going to go to Kendal. She arrives at the station, the Staveley station, at 2:30 or 14:30. So Staveley, so she's too late for this train. 25, she's too late for this train, so she's going to have to take this train. How long will she have to wait for the train? Okay, well, the difference between 30 and 52 is 22 minutes. How long will the train journey take from Staveley to Kendal? Okay, so she's going to get off at Kendal on this train. So this is all the same train. It starts here, ends here. So she's going to get off here at 15:01. So the difference here is going to be 9 minutes. Nice short ride. And okay, Sam, whoever he is, arrived at Kendal on the train that left Windermere at 14:17. So he's on this train. And he's going to get to Kendal at this time. So how long does he need to wait at Kendal until Grace arrives? So we're basically just finding the difference between these two times. So the way I recommend this, try to find the distance to the closest hour, so to 3 o'clock or 15. So that would take us 26 minutes, and then this is more than that, so we're going to add 1 more minute, so it's going to take us, he's going to be waiting 27 minutes. Moving on down, just a few more pages left. Okay, so Kieran buys a car for $8,000, and the following year he sells the car for $7,500. Wow, only has the car for a year. That's not good. Find the percentage loss. Okay, so we need to figure out how much did he lose on this. Okay, so we take 8,000 minus 750, which is going to give us 500. And we want to find out what percentage this is out of 8,000. So you could, again, set this equal to a proportion and figure out what is going to be here. So, 8,000x equals 50,000. So 50,000 divided by 8,000. Or if you have a calculator, you could just take 500 divided by 8,000, which is going to give you, so 0.0625. Now remember, this is not a percentage. This is a decimal. To turn this into a percentage, you need to take this and multiply it by, got it, 100. That's where this would actually be a bit handy. So this multiplied by 100 is going to be 6.25. So he lost 6.25%. All right, moving on to the next one. Ooh, we have some factorizing quadratics, okay? So we need to fill in the boxes here. We need to figure out what to put in here. Okay, so we have x plus 3 times something in brackets gives us x squared minus x minus 12. So the way we do this, the first two numbers, when we multiply them together, are going to give us x squared. So x times, well, x gives us x squared. All right, so the tricky part is here. We need to figure out what are the factors for negative 12. So we could have negative 1 times 12. We could have 1 times negative 12, negative 2 times 6, 2 times negative 6, positive 2 rather. We could have negative 3 times 4, or we could have positive 3 times negative 4. The other factors would just be the same thing but in reverse, so we'll leave that here. We have 6 possibilities. Okay, so these are all the things that the pairs that multiply up to give us negative 12. And here we were actually already given the first one, positive 3, so the other one should be negative 4. So we have minus, so we'll just put in our 4 here. All right, and if you're not sure how to find that on your own, if you need to find both of these, if they don't give you one of these, the way you do that is that you look at this one here, the negative x. Remember, this is like negative 1x. Whenever you add these together, you should get this result. And so you can see 3 plus negative 4 will give you negative 1. So that's how you can check and see that this would be the one. Okay, oops, don't need the PDF. The distance from the Earth to the Sun is 92,868,000 miles. Write this distance correct to 3 significant figures. So this means to the first 3 non-zero numbers we have. So anything bigger than a decimal point is just going to be the first 3 numbers we have, basically. So here it's essentially talking about we have not something in this place value, something here, and something here. So we have 9, 2, but what comes after 8 is going to depend on what comes after that, which is 6. 6 is 5 or larger, so we're actually going to round up to 9, and the rest will just be zeros. So we'd have 92,900,000 miles here. We're done. Let's move on. Okay, a company makes 12 different types of television. The cost in dollars and screen size in centimeters of each type are shown in the scatter diagram. Okay, so you've got 12 different points here that relate cost to size. You want to write down the cost of the television that has a screen size of 65 centimeters. So go down here, find where 65 centimeters is. It should be here. So right between 60 and 70, we go up, and sure enough, there's a point here. Where does this correspond to? Be careful, look at where the cross, the X, is in the middle. And we're going to see that it's not, this isn't touching 300. This is actually somewhere in the middle of these, okay? So be careful with these lines here. We have 300. this would be 1, 2, 3, 4, 5, not, but it's 400, so this is going to be 320, 40, 60, 80, right? So 320, 40, 60, 80. So between these would be somewhere around 310. All right, be very careful. They are fairly precise on these, and at a year 9 level, you also need to be fairly precise with your measuring and your reading graphs. So 300 here, unfortunately, would not cut it. You would need to say something around $310. Okay, now the company is introducing a new television with a screen size of 85 centimeters, and we want to put a ring around the cost that you think would be most appropriate for the new television. We need to explain our answer. So, with a scatter diagram, with a scatter plot, we need to see if there's a correlation, which again there is here, right? The bigger the screen, the higher the cost. We have a positive correlation, so there should be some kind of line of best fit. So if I go and I draw a line where I have roughly the same amount of points on the top as I do on the bottom, I don't know, it would be something like this. Well, maybe not quite like that, but close. And so once I have this done, I can find 85. And 85, if I follow this up, it's going to be around here, which if I look, it's a little over 500, okay? So looking at these, it's nowhere close to 300, nowhere close to 800. It's pretty far from 690, so the only possible option I have would be 530. So it's not exactly there, but again, most of our points aren't exact. They're just close, so this would definitely be the most appropriate price out of the ones they give us. And if we need to explain our answer, we can actually just say exactly what I just said, that it's the closest answer to the line of best fit. Don't write line of best fit like I'm doing. Actually, give me an explanation that, I don't know, 530 is closest to the line of best fit. Even that would be sufficient, okay? Something about being close to something about line of best fit. Okie dokie. So here, use a trial and improvement method to find an approximate solution to the equation. Okay, so we want to give our answer to one decimal place. You must show all your working. These, I assure you, are not very fun. Okay? So we want to find what cubed plus 5 times what will give us 400. If we start with x equals 7, putting this in here, so x cubed, 7 times 7 times 7 is going to give us 343, plus 5 times 7, which is 35, equals 378. So this, is it too big or too small? This is too small. So we're going to need something a bit bigger. Okay, why don't we try, I don't know. 8 is going to be fairly big. We have a cubed here. So let's go ahead and work out, I don't know. So let's try 7.2. Why don't we? Okay. So if we try 7.2 and we put it in our calculator because I do not feel like writing this all up by hand, 7.2 times 7.2 times 7.2, that's going to give us 373.248 plus, let's put it in brackets now, 7.2 times 5 in brackets. It's going to give us 409.248. Now this is too big, so we need to be smaller than this, so let's try 7.1. All right, so going back, we'll take 7.1 and we're going to cheat a little bit, cubed, plus brackets 7.1 times 5 and brackets, which will give us 393.411. Okay, so now we're small again. Okay, so now which of these two is it? All right, so in other words, I know it's going to be one of these two, right? Because I've got too big or too small. It says to one decimal place, but I need to know, should I round up or should I round down? So that we do need to, unfortunately, do one or two more. Let's just double check. So let's go in the middle. Let's try what 7.15 is going to give us, and this should hopefully be enough. So I will take 7.15. I'm going to cube this, and I'm going to add 7.15 times 5 and my brackets. And this is going to give me 401 point something. Doesn't matter. It's big. So I know that's going to be, I know that it should be, again, less than this. So it's going to be, even if it's 7.14, even if it's 7.149, I don't know what it is. I know that whatever it is, I'm going to round down to 7.1. So it should be 7.1 rounded to 1 decimal place. Okay, moving on to the next page, almost done. We have two fair four-sided dice are numbered 1 to 4, and they're rolled and the scores are multiplied together. We want to complete the sample space diagram to show the outcome. So if we're going to multiply the scores, so for example, if I get a 1 and a 2, I'm going to take 1 times 2. So it's going to give me 2. 1 times 3 is going to give me 3, and 1 times 4 is going to give me 4. 2 times 1 gives me 2. 2 times 2 gives me 4. 2 times 3 gives me 6, and 2 times 4 gives me 8. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9, and 3 times 4 is 12. And finally, 1 times 4 is 4. 8. 4 times 3 is 12. And 4 times 4 is 16. All right, so these sample space diagrams are all going to depend on what they're asking you to do, okay? So here, they're asking us to multiply. Sometimes it could be the biggest of two numbers. Sometimes it could be adding them, okay? Sometimes it could just be two different things going on, and you need to figure out what's going on. So read carefully what it's asking. Finally, we want to figure out the probability of attaining an even outcome. So if we take a look, we see that we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 possible outcomes. So we know it's going to be something out of 16. How many of these numbers are even? So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You'll see that actually only 1, 2, 3, 4 of these are odd. So I've got 12 out of 16. If I simplify this, this is going to give me 3/4. So I could leave this as a fraction. If I wanted, I could write this as a decimal 0.75 or as a percentage. Lots of people like to talk about probability in terms of percentage. Either one of these three answers is okay. Oops, didn't need to move all that. All right, so moving on. 2 more pages and we're done. All right. A baby elephant has a mass of 105 kilograms. The elephant increases in mass by 95 kilograms per year. Work out how many years it will take the elephant's mass to increase to 2 tons. Give your answer to the nearest year. All right, so remember, 2 tons is how many? This will give us 2,000 kilograms. And we're starting at 105. So we're starting at 105. We know that each year is going to increase by 95. We're going to say 95 times however many years, and we want to figure out how many years we need to get to 2,000. So the way that we can do this is we just set up this linear equation and solve. So we can move our 105 to the other side, right? We can subtract minus 105. So this is going to give us 95y equals 1,895. Then we just divide by 95. Since this is a calculator paper, we are going to use our calculator. So we take 1,895 divided by 95, which gives us this big long number, 19.947. But they want us to the nearest year, so the nearest full number, 19.9, is going to round up to 20. So right about 20 years. Okay, next we have a circular fish pond that has an area of 20 square meters. We want to calculate the diameter of the fish pond. Okay, so remember the area. Okay, first of all, it's circular. So we have a circle. Remember that the area of a circle is pi times radius squared. And the diameter is going to be radius times 2. So we do know that the area is 20. We can find out the radius. So we're going to take 20 divided by pi. So we'll take 20. You can divide it by 3.14. If you're using a scientific calculator, you can even use just the pi number, the pi button, which is going to give us this really, really ugly number. Okay, so we're going to have 6.3, let's say 6.366. So again, we divide by pi. So we get 6.366 is equal to r squared. So to get r by itself, we need to take the square root. So we will then take the square root of this number, which according to this is going to be 2.523 about. So about 2.523 equals r. Now remember, to get the diameter, this is just going to give us the diameter. So this is 2.523. Diameter, we just need to take this and multiply it times 2. So we go back to our handy dandy calculator, times 2. We're going to get 5.046. Here we could round this to 5.46. That would be around 5.05. Usually 2 decimal places is sufficient. If you wanted to round it to a whole number, this would give you about 5 meters. And finally, moving on to our last question. A trapezium is made up of triangles. Brain-busting material, right? Okay, so triangles ABE and BCE are right-angled triangles. Triangles CDE and BCE are isosceles triangles, meaning that they have 2 equal sides. Triangles CDE and, we already read that. So AE equals 3 centimeters and EB equals 4 centimeters. We want to work out the length of AD. So this is going to be lots and lots of fun. So let's go ahead and label what we know. Let's zoom in a bit. All right. So not to scale, that means that these relationships may have nothing to do with each other, okay, in real life. So AE is 3 centimeters. EB is 4 centimeters. So this is also going to be 4 centimeters. Work out the length of AD. All right, well, this is going to be lots of fun, isn't it? Okay, so we do know that if we have, this is a right angle, right? We can have a squared plus b squared is going to give us c squared. So we'll take 4 squared plus 4 squared. That's going to give us, well, this is EC, right? We'll call it EC squared. So 4 squared is 16, plus 16 gives us, again, our line here, EC squared. So in other words, 32 is the same as EC squared. But we're going to need to take the square root now, and the square root of 32 is about 5.66, so about 5.7. So this is about 5.7. Since these are the same length, this is also going to be the same length. So we've got 3, so to get AD, you have this 3 plus 5.7, which will give us right about 8.7 centimeters. And with that, we have finished our practice exam. If you have any questions about this or anything else, please send me a message. Please talk to me in class. I hope this was helpful. I will see you all in class again. Have a good evening, everybody.